Let us take a look at trigonometric ratios of acute angles in a right-angled triangle. The angles that we're going to be dealing with are acute angles, and the right-angled triangle is really the only triangle in which you can find these ratios. Alright, remember also that a ratio is really one quantity divided by another quantity, and you show the value usually in the fractional form, but you could also in some cases show a ratio as like 2 to 3 or something like that. Right? But it's a number divided by another number. Now let us find a triangle somewhere. We have a triangle. No, this is our set square. It's shapes that we want to look at. Let us look at the shape of a triangle, a right angle triangle. Nice. We have a right angle triangle here. Let's increase the size of our right angle triangle. Alright. Now we can always make an adjustment to these sizes, or the lengths and angles of the side. Now I want to make sure that we have a right angle triangle here, so I read from my protractor. My protractor here, it shows that this indeed is right angled. Alright, so we do have a right angle right there. I want to make sure that everything is okay with our right angle triangle. I'm magnifying glass. Yeah, it's a right angle triangle. Now let me see what this angle measures. Guess what? I want it to be about 30 degrees. I want this angle to be about 30 degrees, so let me kind of shift my triangle. Let's get a closer look. Alright, it's just about 30 degrees. Just about 30 degrees. Nice. Now we know that that's our 30 degrees. This is expected to be what? Let's turn our protractor upside down, and you, as expected, this angle here, let's spin it this way. Nice. That angle is from this end we have 60 degrees. Alright, 60 degrees. Now we want to measure the sides of this triangle. Where's my ruler? Here's my ruler here. Let's measure the length of this side. Let's have a longer ruler. I want my magnifying glass to see what's really happening in these corners. We start at 0. This here is 15.56, about 15.6. Let's call it 15.6. Alright, so this is 15.6 centimeters. 15.6 centimeters here. I want to know the measurement up here. Let's line it up well and measure this side of the triangle. Yes, this is 8.1 to 8.2. Let's say that is 8.2 centimeters. So we measure it as 8.2 cm. Alright? So this length is 8.2 centimeters. Now, what is this length here? I want to measure from here, going down this way. Alright, so we start from 0, and this looks like 17.6 centimeter, just about 17.6 centimeters. So this side is 17.6 cm. Now we're going to be doing some things with these measurements shortly. Alright, but before we do that, you remember that in a right angle triangle, right here is a right angle. Now let us concentrate on a particular angle, this 30 degrees. We already measured it and see that this angle is 30 degrees. Now we have to give the sides of this triangle some names. The 30 degrees is on my right. So over here is my, it would be your right as well. And over here is on the left. Left and right are opposites of each other, right? So this side that measures 30 centimeters, I call it the opposite side to the 30 degrees. So we call it opposite to the 30 degrees. It is the opposite side to the 30 degrees. And it measures 8.2 centimeters. This here, it runs alongside the 30 degrees. It runs alongside right here. Alright? So what we will do is say that this side is, it is adjacent to the 30 degrees. Right? Just like when you have a minor road run alongside a major road, you say that road is running adjacent. It's an adjacent road. And then it might join that road. It runs right along that other road, so it's an adjacent road. And then you have this side. If you should draw the right angle triangle like this, alright, let's say you draw it like this. If you should draw the right angle triangle like this, and the right angle is here, what you will find is that the right angle is on the left hand side and this side is on the right hand side. So if you should turn this triangle that way, this side here that measures 17.6 is opposite to the right angle. We have a nice little name for it. It is called the hypotenuse. The hypotenuse measures 17.6 centimeters. Alright? Now, trig ratios. Whatever the size of the triangle, these ratios will come out the same. Suppose you say you want the ratio of the opposite side divided by the hypotenuse. What you would have here is 8.2, the length of the opposite side to 30, divided by the hypotenuse. The length of the hypotenuse is 17.6. Now, it doesn't matter whether this triangle is big or small or medium. As long as this is 30, I can assure you it's going to work out just the same. And you can try it on paper with a different triangle, with two different triangles, one big and one small, and you will see how it's going to work out. But let's finish up what we are going to be doing. 8.2 divided by 17.6. 8.2 divided by 17.6. What's that? 8.2 over 17.6 equal 0.465. Now, to one decimal place, it would be 0.5. So let us call it 0.5 to one decimal place. Now, suppose we look here at this side over here. We can say that this side, compared to the hypotenuse in terms of lengths, we say that this is the opposite to 30. No, we did that. That's what we did a while ago. Let's try the adjacent, or the opposite and the adjacent. The opposite divided by the adjacent in this case is what? 8.2 divided by 15.6 is going to be 8.2 over 15.6. What's that? Let's see. 8.2 over 15.6 equal, oh my, 8.2 over 15.6 equal 0.526, call it that, around 0.526. let's call it 0.5 to one decimal place. Alright, let's call it this. This was what? Let's put it to three decimal places. We're taking off too much. This was 0. How much again? Let me try and remember. 8.2 over 17.6. 8.2 over 17.6 equal 0.466. 0.466 then. So we have 0.466. Now, let's get rid of this triangle and write the other one over here. So remember, we have this, and something else over here. Suppose we compare the adjacent to the hypotenuse, 15.6. Let me write adjacent first. AJ for short over the hypotenuse. Instead of writing out the entire word, just write the first three letters. How did I spell adjacent like this? I left out the D, or did I press the D and it didn't register? We just write the first three letters instead of spending all that time and energy and ink and so on to write out the full word. Adjacent divided by the hypotenuse. 15.6 divided by 17.6 equals what? Let's see. 15.6 divided by 17.6 equals 0.886. About that. 0.886 let's write that down as our answer. So we have 0.886. Now you have a special name for these ratios. The length of the opposite divided by the length of the hypotenuse is called the sine. And since we are comparing opposite to the 30, it would be sine of 30. Having to squeeze in this one, fighting for space. Here, remember, it's the 30 degrees we're talking about. So when we say opposite, we're talking about the opposite side to 30. Opposite divided by the hypotenuse. Let me write the hypotenuse here properly. Oh, adjacent. Let me write it properly. ADJ. You see, I have to make sure I write it down well enough. So, in this case, the opposite divided by the adjacent is called the tangent. And it is a tangent of 30 degrees. Let me put the 30 in brackets. And then the adjacent divided by the hypotenuse. When you're talking about the adjacent side divided by the hypotenuse, you're talking about which side is adjacent to the 30 degrees. So the adjacent to the hypotenuse is called the cosine, and it is the cosine of 30 that we're dealing with here. Cosine of 30. But again, it's kind of inconvenient to be writing out all the entire words, so we just call this cos, we call this sin, and we call this tan for short. Alright, now this is what we got. Remember, we did this by measurement, so it's not going to be perfectly accurate. To get the perfectly accurate value, we use our calculator. We found the cosine of 30 degrees. Let's find the cosine of 30 degrees on our calculator. My calculator there on the right board doesn't have sine and cosine. I make sure my calculator is in degrees. Right? Angle is in degrees. Not gradients, nor radians. So I say the cosine of 30 degrees equal 0.866. The accurate value we got from the calculator is 0.866. Kind of close, not too bad. That was 0.886. 0.866. The sine of 30 degrees. By measurement, we got 0.466. Although it could have been a little better, but you can have a very big triangle. I'm sure that if you're doing it on paper, with real paper, real pencil, real ruler, you'd get it much more accurate than I did on the computer screen here. Well, let's find the sine of 30. Sine, let me clear my calculator first. The sine of 30 degrees equals 0.5. So we got the sine of 30 as 0.5. Kind of close toward 0.466. Right? We would get 0.5 to one decimal place anyway. And then the tangent of 30. Let's see what we get on the calculator. Clear our calculator. Tangent of 30 degrees equal 0.577. What do we get? We got 0.526, and this is 0.577. Alright, that's not too close, but it's kind of close for measurement on a screen. All right. Now, those are the sine, cosine, and tangents for our 30 degrees. What we will do shortly, or in the next video after this, is find it for the angle up here. Let us label the angle up here from now. Which angle is this? What's the size of this angle? You remember it was 60 degrees. So we're going to deal with the 60 degrees, and we will kind of get rid of the 30 degrees for now. So let's just erase the 30 degrees here, and we will concentrate on the 60 degrees next time. So I will see you in the next video.